This is a graphing motion problem where you have to draw both a distance versus time graph and a velocity versus time graph for an object that first moves forward slowly, then stops and rests, and then speeds up gradually. Afterwards, it begins to slow down to rest for an instant and proceeds to speed up again, moving forward. Actually, as I look at this, I realized that when I said I move, it stops, rests, and gradually speeds up. When I meant gradually speeds up down here, I meant moving backwards. I forgot to put that in to give it a direction. Okay, so let's draw this graph. I'm going to start with distance versus time. And I have several different parts of this graph. We have, if I slide up here, we have an object moving forward slowly at a constant speed. Is one area. It then stops and rests. There's a typo there. It then speeds up gradually. Keep that blue. And then after a few seconds, it begins to slow down. That's the last one. It's at rest for only an instant. That's important to note. And then proceeds to speed up moving forward. Make that pink. So I've got all these individual parts of the graph. Whenever you have a complicated motion like this, it's best to break it up into the various parts. So we'll draw the first one, the red one. An object moves forward slowly at a constant speed. So moving forward means that I should have a positive slope. Slowly means that slope is not too steep, and constant speed means that it should be a flat line. So I will have a straight positive slope line that's not too big. So something like that. It then stops and rests for a few seconds. So something that is stopped for some amount of time will have a slope of 0 because its velocity is 0. Remember, the slope of a distance graph is the value of the velocity. This object then speeds up, moving backwards gradually. So to me, gradually was meant to show that it speeds up, but not super quickly. Speeding up means my line will no longer be straight, but in this case, the line needs to have increasing steepness because the speed is increasing. So I'm going to end up with a line that is parabolic, curved, and not too curved, sort of a moderate curve. After a few seconds, it begins to slow down. So what that means is after a few seconds, the shape of this curve, those of you in calc will know this word as concavity, but I'm basically going to flip the curve. Instead of being curved upside down, it's going to be curved right side up. That shows me slowing down because the slope of the line is becoming less. And then it's at rest only for an instant. So instead of, as in the purple where I had a flat, straight line for some amount of time, in this case, I'm not really going to have a flat line for more than just a split second. So it's really just going to look like a parabola. And so after this instant, so here I'll actually do a bright blue dot to show you the instant at rest there. And then afterwards, it's going to speed up moving forward again. So I now need a positive slope that gets steeper. So it's going to be the other side of a parabola. And I want you to notice that this is at rest for an instant. Now, the next part of this question was to draw a corresponding velocity graph. So I'm going to put a velocity graph down here. I'm going to try to line up the various parts of the graph from the distance versus time graph to the velocity graph. So what I mean by that is the red section on the distance versus time graph should correspond to the red section on the velocity graph. Before I do that, I want to quickly review one basic idea, and that is that the slope of the dt graph equals the y value of the vt graph. So what I mean by that is, imagine I put numbers on this. If we had given the detail that the object moves forward at positive 4 meters per second, that would be a positive constant speed. When I go down to draw the velocity graph, I would draw a flat line where the value on the y-axis would be positive 4 meters per second. So the slope of the dt graph is the value of the vt graph. So continuing with this, the slope of the purple section there is 0 because the object was at rest. So that means the slope of this next stretch is 0 on the dt, so the value on the vt is 0. Be a little on the long side. Back up. Make that a little thicker so you can see it. Now, here's a place where mathematically I should not draw this next purple line. In physics, I'm not going to worry about that right now. The reality is you can't have a vertical line here. That implies that the object changed its velocity instantaneously without any time passing, and that didn't happen. But you can worry about that in your math class. The next part, we have an object speeding up, gradually moving backwards. So I'm talking about this first stretch of the line. I'm talking about from here to about here, where I have an upside down parabola. An upside down parabola, first of all, any curve on a dt graph will generate a straight line on the vt graph. And the way I like to look at it is, what was the velocity early on in this curve? Well, early on, actually let's go back up. Early on, the velocity here, the slope, is pretty flat. Maybe like -1 meter per second, I'm making that up. But later on, it was much steeper. Maybe it was -3. So we see that my velocity value is getting steeper, bigger, but negative. So that's going to generate a line that looks like this. Now, when I get to that next section, the opposite is going to happen. If we go to this section, we see that while I might have been at 3 meters per second here, negative, soon I will be at 0. I will be at 0 for only an instant, though. So what this means is I'm going to draw a graph of a line that returns to 0. Oops, try to make that straight. Now, we said that the object was at rest for only an instant, so that means I'm going to pass through velocity 0, but unlike the purple case, I'm not going to stay there. I'm just passing through. And then now I have a line going like this because I'm showing an object that is speeding up moving forward. This point here shows at rest for a moment. This is the end of this video lesson.